I'm Kelsey, an OpenSciEd teacher and facilitator. This video is going to go over lesson 13 in unit 6.2. This is the last investigative lesson in this lesson set, so let's take a look at what we have. First of all, how we got here. During lesson 12, we figured out that not all particles in a sample of matter have the same kinetic energy. Kinetic energy is transferred from one particle to another in particle collisions. Temperature is a measure of the average kinetic energy of the particles in a sample of matter. And the total kinetic energy of a sample of matter is the sum of the kinetic energy of all the particles in that sample. If you add more particles to the sample, the total kinetic energy increases, but the temperature, the average kinetic energy, might stay the same. In this lesson, we are wondering, how could the motion of particles on one side of a solid wall affect the motion of the particles on the other side of that wall? Here's a lesson at a glance. It's an investigation lesson. It's 2 days long. We have 45 minutes of material prep. We have hands-on investigation, and we need devices for this lesson. We have some student videos that can be used for students who miss the hands-on activities, and a teacher video for prep. Here we're looking at day 1 of this lesson and the first of 2 sense-making loops. We start by looking together at a simulator that is similar to one we used in the last lesson. Then we have a hands-on investigation using baking trays and marbles to investigate particle collisions between solids, liquids, and gases. Then we use what we figured out to explain one of our previous cup experiments. From all this, we figure out that collisions between particles in different states of matter, gas, liquid, and solid, can transfer energy between them, causing temperature changes. On day 2, we have a second sense-making loop. Here we use another simulator to carry out investigations or several investigations into particle interactions between solids. And again, we apply all this to explain what's going on with the cup system. From these investigations, we figure out that the more particles in a sample are in contact with another sample, the faster the energy will transfer between them. And the more particles an object is made of, the more energy must enter or leave to change the temperature of that object. So we figure out that the particles in solids vibrate back and forth in place. Collisions between particles in a solid, liquid, and or gas can transfer kinetic energy or motion energy from one particle to another. The more particles in a sample of matter that are in contact with another sample of matter, the greater the amount of particle kinetic energy is transferred from the warmer piece of matter to the cooler pieces of matter over time. And the more particles an object is made of, the more energy must leave or enter the system in order to change the temperature of that object. So we're left wondering, does our evidence support that cold is leaving the system or that heat is entering the system? Key moments in this lesson. So in the first sense-making loop, students are gathering data on how particles of different states of matter can transfer energy between them. They're given this graphic organizer right here. This graphic organizer they use to add their data as they explore the simulator and use the marbles to investigate this. You're also discussing these things in pairs, groups, and as a class as you go. In part 6, students are asked to then use what they have figured out today to explain results from the water bath lab that we did in lesson 9. This is a great opportunity to give students individual feedback on their progress at using evidence to explain temperature changes in matter. In the next lesson, they will be doing this as a summative assessment. Part 12 is the navigation at the end of this lesson and the second sense-making loop on day 2. In this loop, students use a solids simulator to investigate how particles of solids interact, and they figure out that particles of solids vibrate in place, passing energy between them. So at the end of these investigations, we have another place to check in and give individual students feedback. The students are asked to use what they have figured out to explain the original phenomenon of a cold drink warming up, and then for home learning, pick a related phenomenon to explain as well. All of this is practice at using everything we've figured out so far in this unit to explain how things change temperature. And again, they will be asked to do this for a similar phenomenon as a summative assessment in the next lesson. So I have 4 quick tips and tricks for material management in this lesson. First is using the simulation. This is the same tips that I gave in the last lesson, but we have two simulators used in this lesson. The first is used as a demo, and the second is used by students to gather data. So the tip is just to make sure these things work, test them out on the devices that are available to students if you have them, or be prepared to do this as a demonstration if student devices are not available. And then lastly, I just like to have student pairs or groups use just one device so that they're forced to work together and talk with each other as they're investigating. In part one, navigation, the navigation into this lesson, it's a short whole class discussion where we recall what we have figured out about particles gaining and losing energy when they change temperature, how particle collisions cause energy to be transferred, leading to temperature changes. So it's at this point that you can give students another term, thermal energy. There is guidance for this in the teacher edition, but it's easily missed, which is why I'm pointing it out here. In the previous lesson, we co-developed a definition for temperature, and now we have a second word we can use to explain what's going on when things change temperature. In part two, we analyze the motion of colliding particles in a computer simulation. This is a demo, and you don't spend a lot of time on it. But in the simulation, I like how you have the option to show speed because it shows that one particle is gaining energy and one is losing energy when they collide. This is really great evidence for students, and it's also great to reteach students that idea of gaining and losing energy in particle collisions. And finally, in part five, when we are using the model for this hands-on investigation, the students do several investigations here. First, they have just two marbles colliding representing gases. Then we have the magnetic marbles to represent solids interacting with gas and liquid particles. While students are exploring this, highlight and elevate those student observations that the magnetic marbles representing the solid particles move some when the gas particle collides with the outside of the cup wall. You might need to encourage students to try varying amounts of force with this gas particle so they can see the liquid particles inside the cup moving as a result. If they're moving that single gas particles marble like too softly, they won't see it. So you might need to encourage them to try different amounts of force. So for our word wall management, we add thermal energy to the word wall here. The teacher edition doesn't call out to chart anything that the students have figured out in this lesson, but it wouldn't be a bad idea to add to the chart created in the last lesson, detailing how energy can transfer between the three states of matter. And that's it. In the next lesson, it's an investigation lesson, but also putting pieces together. And we're wondering then, does our evidence support that cold is leaving the system or that heat is entering the system? And that will be in the next video.